everybody, welcome back to our fourth lesson on planets. Today we are going to be using the idea of the Earth's rotation to actually explain day and night and the apparent movement of the sun across the sky. So then my question for you is, does the sun actually move? If you look out into the sky, obviously don't look directly at the sun because that is dangerous, but it appears as if the sun is actually moving across the sky. I'm going to show you a video, a time-lapse video of the sun moving across the sky, and I want you to have a think while you're watching the video about what do you think actually happened. Is the sun moving across the sky, or is something else happening? So have a think whilst we're watching this video. I'm just share the screen. So here we are, just going to start it from the beginning. Okay, so you can see here the sun is in the top corner. Slowly moving across the sky, you can see all of the clouds moving in the opposite way past it. So what do you actually think is happening here? See, it still appears to be moving across the sky. We're getting closer now to the horizon. The clouds are still moving in the opposite ways. The houses and all of the trees are staying still in the picture then. So what do you actually think is happening? As you can see now, as we're getting closer to the horizon, we're getting closer to the sunset, and soon we're going to begin to see the sun drop down behind the horizon just like that, and now this is the beginning of the sunset. As the sun starts to set behind the horizon, it's actually getting darker as nighttime is falling. And eventually we get pitch black. This is sort of in the middle of the night. Okay, let me go back to my screen. New share. Okay then, so what was actually happening then in that video? It appears as if the sun is moving across the sky. What's actually happening? So the sun actually stays in one place. It stays in the same place in relation to the Earth. However, it appears to be moving because of the movements of the Earth as it orbits around the sun. So in the morning or in the late afternoons, shadows are longer, whereas they're actually the shortest in midday. And this is because the sun appears to be the highest in the sky and is directly above us at midday. So the original sort of idea of the sun moving is the sun was the thing that moved across the sky, is where we actually have lots of traditional stories which explain day and night come from. So for example, we've actually got Helios, who was an ancient Greek god. And the ancient Greeks actually believed that Helios actually pulled the sun across the sky each day in a chariot. So now we know that it's not true because we know that the sun actually stays in one place and the Earth orbits around the sun, and as it's orbiting around the sun, it's actually rotating on its axes, which gives us night and day. So what you can actually do to tell the time by using the sun, using the whereabouts the sun is in the sky, is you can actually create a sundial. So this is going to be an optional task. I am going to attach the worksheet to the assignment, but it is completely optional. If you don't want to do it, that's fine, but if you do it, that's fabulous. Just send me in some pictures. So the worksheet that is going to look a little bit like this. You just need to cut out one of these triangles and use this as your sundial. You then put the triangle onto the sundial base, which is this line here. And then you point this bit here to north. What you will then see is your shadow from your sundial, from your triangle, at different times of the day will land upon the lines already given. So at 12 o'clock, midday, the shadow will be straight forward and it'll be the shortest shadow. As you come earlier in the morning or later on in night, the shadows will actually get longer. If you don't have a printer at home, what you can also do is use a paper plate and stick a pen into it. And what you can do is at 12 o'clock, you'd mark off where the shadow is, and this would be midday. Then you need to check the time again, and at 1 o'clock, you would mark the shadow, and that would be 1 o'clock. 2 o'clock again, you need to mark the shadow for each one. And then what you can actually then use this to tell the time. So your bit of a how to do is you need to make sure you place the sundial in the sunshine and make sure that it's on something level. It won't work properly if it's not level. You then need to make sure that you turn the sundial so it's facing south. You need to use a compass to do so. If you've not got a compass handy, smartphones actually have a compass on them, so you can use that. Or if you're using the worksheet that I've given you, it says to point this section north. That's fine. So you can either point it south or north. Obviously, they're opposites. So now what you can actually do is you use the sundial to tell what time it is. So every hour you mark off the time and the position of the shadow on the card. So if you miss an hour, don't worry too much. So for example, if you manage to mark off 12 midday and 2 p.m, you can work out 1 p.m. as it will be the middle of these two shadows. Once you've marked down where all of the daytime hours are, you will have a fully working sundial and you can use it again to tell the time. So I just want to reiterate that it is an optional task, but if you do it, that's fabulous. Just send me in some pictures. So you can either use the worksheet that I will attach to make your sundial, or you can use a paper plate with a pen into it. All you can do is get some card, cut out a circle, cut out a triangle and stick it on. Again, it is just really important that you find north and you point it towards north. Okay then, so back to the question, does the sun move? So we found out that the sun actually doesn't move. The sun stays in the same place, whereas the earth rotates around it. As it's orbiting, it rotates on its axes. The part of the earth that's actually facing the sun is daytime, whereas the opposite side won't have the sun shining on it, which means it is nighttime. So I'm actually going to do an example. You can see my camera up here. So I've got an apple. It's a bit of a funny shaped apple. Ignore that. Pretend it's a sphere. I've got my apple, and I'm going to shine my torch from my phone as the sun. So as my torch is shining onto the apple, this side here that can see the sun, you can see the torch is reflecting off it, it's daytime. Whereas the opposite side, this side here, it's nighttime. It's got no sun shining on it. It's in the middle of the night. As this the earth rotates on its axes, you can see that now a different part of it has the sun shining directly on it. So now this is now daytime, whereas the other side is nighttime. As you can see, there's a shadow. So the reason why we see the sunrise in the east yet set in the west is because as it is rotating around, you can see the sun is starting to appear coming from east around to west. And you can, so whichever side the sun is facing, whichever side is directly facing the sun will be midday. And then as it moves away, it will get later on in the evening. Okay, so we're going to watch a quick video, a bite-sized video, just another further explanation on the movement of the earth, the rotation of the earth, which explains day and night. So I will just show you this video. Here we go.
This is a model of our Earth. This is the sun. If I turn this knob here, I can make the Earth spin round and round on its axis just as it does in real life. This side, the light from the sun can reach it, so it's in daytime. But this half here, the light can't get to it because this bit's in the way. So if you're around here, it's going to be dark, it's going to be night. And the sun does rise in the eastern half of the sky and set in the western half. And the reason we see it doing that is because our Earth is spinning round on its axis. And we can use my little plastic person here to help us. If I put him here on England, and I now make him be a little bit silly and look straight at the sun, something you wouldn't do because you would damage your eyes, we can get him to look at the sun and we see he needs to look over his left shoulder towards the east, towards Russia. By the time we get round to midday, he needs to look towards the south, but higher in the sky to see the sun. And by the time we get round to the evening, he now needs to look over his right shoulder, which is towards America in the west. Let's have a look at how the shadow changes. Here we are in the morning, and you can see the shadow across here. And as the Earth spins on its axis, we see the shadow moves around in a clockwise direction and gets shorter and shorter. And now at midday, the shadow's at its shortest, and it's pointing towards the north. And as the Earth carries on spinning, the shadow gets longer and longer again and ends up facing the opposite way to what it was in the morning.
So that's why, as the day goes by, the direction and the shape of the shadow changes.
Okay, so that's a little bit further of an explanation then as to how the Earth rotates, and it shows us, and it gives us day, which is the side that's directly facing the sun, and then nighttime is the opposite side. Okay then, so what I'm going to do is I'm going to share and show you what your worksheet is going to look like. So this is your worksheet here. What I want you to do is I want you to finish off the sentences using the word bank above to explain why we have nighttime and daytime. What I would like you then to do is in this box below, it says any other information and explanations for night and daytime, please write below. So any other facts that you can think of, anything else that you learned from watching the video, which I will be attaching to the assignment, any further explanation sentences for you to go into more detail, you can write in this section here. Now, most of you, I will be expecting some information to go into this box. Okay, so that is it for your 4th lesson on planets today. Tomorrow is our last lesson on planets. Just make sure if you do a sundial, please email it in because I would love to see some pictures of it. In this any other information part, you could draw a picture, draw a diagram on a piece of paper, take a picture and put it in. You could also show me a diagram, take a picture again and put it in, or you can just write some extra sentences and extra facts. I will be sharing, so this assignment will be on Teams and it will be posted straight away as soon as you watch the video for you to fill in, and I look forward to reading your assignments. Thank you.